This is the third part of our discussion on dividing polynomials, and we're going to look at something called synthetic division. So in part 1 we looked at long division of polynomials. In part 2 we looked at the factor theorem, and now we're going to look at synthetic division. We can think of synthetic division as a shortcut that's easier and quicker to do than long division. So since it's easier and quicker, a shortcut, we would think that we'd always want to use it, and I would say yes, we do. There's certain times we can't use it. We can only use synthetic division if there's no a value in front of a factor. So in other words, remember in our last lesson we saw that factors, if they're written in the form ax minus b equals something, or if we're going to set them equal 0, then that a value there is going to cause a difference as far as how our solution goes. So basically all we need to know for now is if you see a number in front of the x for a factor or for a division, we can't use synthetic division in that case. So let me do an example to make that a bit clearer, hopefully. So we want to divide x cubed plus 2x squared minus 5x minus 6 by x plus 3. All right, so x plus 3, there's no number, there's no a value in front of the x. It's not 2x plus 3, it's not negative 5x plus 3, it's just x plus 3. So as long as it's just x plus or minus something, we're good. So this is one where we can use synthetic division. The 0 related to this factor is x equals negative 3, right? So there's our related 0. So here's how we set up synthetic division. We take our 0, negative 3, and beside it we write a partial box. And in that box we're going to write the coefficients of all the numbers that are in our dividend, in the one that I've highlighted in green. So the coefficients from left to right are 1, 2, negative 5, negative 6. Oops. Let's keep things color-coded so we can see where they came from. So again, what I've highlighted in green inside that box are just the coefficients from the original polynomial. And the way synthetic division works is like this. We always start with whatever the first coefficient is and just bring it down below this line. So if it's 1, then we just write a 1 underneath. Now what we're going to do is we're going to take this negative 3, the 0, and multiply it by whatever we just brought down, whatever's underneath. So negative 3 times 1 is an easy one. That's positive 3. Sorry, positive 3. That's negative 3. Negative 3, and we'll bring it up and stick it in here. So again, we did negative 3 times 1, and we got negative 3, and we write it just above the line. So this is just showing what I'm doing, so I'll get rid of those red bitties. And we can see that we've got negative 3 there. Then what I want to do is I want to add these two numbers together. So we're always going to be adding with synthetic division. In long division we subtract, in synthetic division we add. So we've got to be careful that we're clear on which one we're doing. So 2 plus negative 3 is equal to negative 1. And then I can do it again. So then I'll take my negative 3 and I'll multiply it times negative 1 here. That gives me an answer of positive 3. And I bring that up to the next column over. Then I'm going to add these two together, and I'm going to get negative 2. Then I'm going to do negative 3 times negative 2, which is positive 6. I'm going to bring that up to the last spot. I'm going to add those two together, and I'm going to get 0. All right. This 0 is, again, the remainder. We saw in the last lesson that when we're doing division, if we divide by a factor, our remainder should always be 0. This is the remainder. So the last number is always the remainder, and it should be 0 if it's a factor. These numbers over here are coefficients of the quotient. So if I wanted to state my final answer of what I get when I take x cubed plus 2x squared minus 5x minus 6 and divide it by x plus 3, the answer would be x squared. Actually, let's work backwards. This is my constant term. This is my coefficient of my x term. This is my coefficient of my x squared term. So from all that, putting it all together, I'd have 1x squared minus 1x minus 2. That's my final answer. And there could be more numbers there. There could, if it was a longer polynomial that I started with, then I could have x cubed, I could have x to the 4, but we always start from the right. We start from beside the remainder with our constant term, and then our x term, and then our x squared. Then we'd have x cubed if there were more, and then we'd have x to the 4, and so on. Okay, so how can we use that to do factoring then? So we're just told we want to factor this. All right, so we saw that with the factor theorem, we can figure out what a factor of this would be. So we know that the factors of this polynomial have to somehow be related to the constant term. So I can consider numbers that are have to do with plus or minus 1, plus or minus 4, because 1 times 4 is 4, or 2 times 2, right? So plus or minus 2. I don't need to write it down twice, though. But it would be 2 times 2. So those are my only possibilities. Again, I'll start with the easiest one. Let's start with f at 1. If I put 1 into the equation, I get 1 minus 5 plus 4. And I got lucky with the first one. Turns out that f at 1 equals 0. So x minus 1 is a factor. That means that I can use positive 1 for my synthetic division. So I'm going to set it up like I did just above, x equals 1. So I'm going to put 1, and then I'm going to draw my box. I'm going to get my coefficients. So I'm going to go back to my coefficients here, and I've got a 1 in front of the x4. But then notice what's happening. How can I highlight this even more? What I'm circling green, notice how between x to the 4 and x to minus 5x squared, there should be an x cubed term. There isn't one. It just means that the coefficient would be 0. But I can't leave that out. I still have to put that 0 for the x cubed in here. Okay? So the 1, this was the coefficient of my x to the 4 term. Then I have 0 x cubes Then I have a negative 5 in front of the x squared. And then once again, there should be just an x term between x squared and the constant term. So I must have 0 for the x term. And then I've got my 4. So coefficient of the x to the 4, coefficient of x to the 3, coefficient of x squared, coefficient of x, and constant term. That's the way this one lays out. I need to put those zeros in there because things go wrong quickly if you don't. So the steps were, bring the first one down, whatever it is, it's a 1, multiply this times this, and then move it up, and I've got a 1 here. All right, I'm going to stop circling things so much since we've done it a few times, but just a reminder again for the first one to get us started. I'm going to add these two together, right? I'm going to add those two together, and I'm going to get a positive 1. Then I'm going to do 1 times 1, bring it up, and I've got 1 there. Negative 5 plus 1 is negative 4. Then I'm going to do 1 times negative 4. Bring that up. That gives me negative 4. Add those together. I get negative 4. Then I'm going to do, I'll just circle one more time, 1 times negative 4. Bring that up. After I multiply them together, I got negative 4. And, of course, that means I'm going to have negative 4 when I bring it up top. Add those together, I get 0. Okay? Great, I got 0 for my remainder, that's what I want. This is my constant term, this is my coefficient of my x term, coefficient of a squared term, we just count over from the right, coefficient of a cubic term. So the answer is that we've got, that this is going to be x cubed plus x, so 1x cubed, if you want to write the 1 in front, plus 1x squared minus 4x minus 4. So my original equation was x to the 4 minus 5x squared plus 4. So I've factored it a bit now. I found that one factor of x minus 1, and I know that if I multiply that times x cubed plus x squared minus 4x minus 4, that's equivalent. But now, if I want to factor this completely, I'm not done. I need to keep going. So in other words, I need to factor this part. All right, well, I can go through the whole process again. So I've already had a factor of 1. Looking at my constant term again, it's still 4, so I know I can use plus or minus 1, plus or minus 2, plus or minus 4. I've already used positive 1, so let's try negative 1 this time. So if I do, for this, if I stick negative 1 in here, if x equals negative 1, what happens? Well, I'll get negative 1 plus 1 plus 4 minus 4 equals 0. So I get that's another factor. X plus 1 is another factor, meaning that x minus 1 is another 0. So I know that I can then go through the process again this time using x equals negative 1. So I put negative 1, draw my box, take my coefficients. This time my coefficients are coming from just what I've highlighted in yellow here. So 1, 1, negative 4, negative 4. Bring down the 1, multiply it times negative 1, and then move it up top. I get negative 1. Add them together, 0. 1 times 0 is 0. Add negative 4 and 0, I've got negative 4. Negative 1 times 4 is positive 4. Add them, I got 0. So you can see how synthetic division goes quick once you get into the swing of it. Here's my remainder. And what I've got left, this part here is the coefficient of x squared plus 0x minus 4, or I could just write it as x squared minus 4. So, let's take it again. So again, my original was x to the 4 minus 5x squared plus 4. We already saw that we could do that as x minus 1 as one factor. We found another factor of x plus 1. And now we know that if we multiply that times x squared minus 4, it's broken down a bit more. Now it's down to a quadratic on the end. I'm not quite done yet because I can factor this farther. This one happens to be a difference of squares. So I'll keep my first two factors the same. Factor x squared minus 4, and that gives me x minus 2 times x plus 2. This is my fully factored polynomial. Again, what that's good for is it allows me to graph things. This question never asked me to graph it, but if I was to throw on an extra thing and say, well, draw a sketch of this polynomial, I could do that now because I have zeros at -1, +1, +2, and -2 from those factors up above. I know it's degree 4 with a positive leading coefficient from when it was in standard form. I know it's got a y-intercept of +4, so maybe that's here. So if it's got a positive leading coefficient, even degree, it's going to go from quadrant 2 to quadrant 1. The sketch would look sort of like this. Again, that wasn't in the question, but you can see how fast it is. I'd come that far with the factoring that drawing a sketch became simplicity at this point.